Welcome once again. In this session, we are likely to discuss the relationship between Q function and complementary error function, which we have already discussed in last video lectures. So Q function is Q function y equals to 1 upon under root 2 pi integration of e to power minus x square by 2 into dx, taking limit y to infinity. And complementary error function is denoted by 2 upon under root pi integration of e to power minus u square into du, taking limit u equals to x to plus infinity. Now, for our convenience and for comparison purpose, we can also write Q function having limits same as complementary error function. So we take another real value, that is small u, and integrate with respect to du. And we get Q function x equals to 1 upon the root 2 pi integration of e to power minus u square by 2 into du, taking limit u equals to x to infinity. So after making these changes, the Q function and complementary error function are quite comparable. Now, as we have already discussed that Q function is equals to the area of positive tail of Gaussian PDF, and after comparison we find that the limits u equals to x to u equals to infinity shows the positive tail of Gaussian PDF, that is called Q function. And these limits are same for complementary error function. So we can say that the Q function corresponding to the complementary error function. Now, as the complementary error function having a range from x to plus infinity, so on the basis of this observation, we introduce a error function having limit from u equals to 0 to u equals to x, and it is denoted by error function of small x, and it is equals to 2 upon under root pi integration of e to power minus u square into du, taking limit 0 to x. And from here we can express the error function that is same as complementary error function, but only the difference in its limit, that is from u equals to 0 to u equals to x in case of error function. And the complementary error function is obtained by taking limit u equals to x to plus infinity, which is same as Q function, which is the area under the positive tail of zero mean and unit variance of Gaussian PDF. Now we are ready to find the relationship between Q function and complementary error function as well as error function. For this, we first take the expression of complementary error function and put x equals to x upon root 2 in left side and u equals to u upon root 2 in right side. Now differentiate both sides, we get du equals to du upon root 2. So in place of du we can write du upon root 2. Also in the expression of complementary error function, we take 2 to the left side as 1 upon 2 complementary error function of x upon root 2 and put du equals to du upon root 2 in the right hand side. After this arrangement, we get 1 upon 2 complementary error function of x upon root 2, which is same as Q function of x. So Q function of x equals to 1 upon 2 complementary error function of x upon root 2, or we can write complementary error function of x upon root 2 equals to twice of Q function of x, or the complementary error function of x equals to twice of Q function of root 2 x. Also in place of complementary error function of x upon root 2, we can write 1 minus error function of x upon root 2 and become a relationship between error function and Q function. So 1 minus error function of x upon root 2 equals to twice of Q function x, or error function of x upon root 2 equals to 1 minus twice of Q function x. Also it can be written as error function of x equals to 1 minus twice of Q function of root 2 x.